Hi there. If you have run a Tukey test inside of SAS, you know that programming it out takes some effort. It's not super hard, but compared to Minitab, it is much more difficult. So I'm going to show you here inside Minitab how you can get that Tukey pairwise comparison data. So what you're seeing here in this example, we have a worksheet with control F1, F2, F3. This is sample data from Penn State University, from their online Stat 502 course. And the data is looking at plants' heights. These are each of the observations. The height of a given plant dependent upon the treatment group that it was within. So control group received no fertilizer. F1 received fertilizer 1. F2, F3, different iterations of the fertilizer or maybe amounts. It's not clear, but it's not really important for this example. So you've got this data here, and we need to run a one-way Anova on it, as well as generate a Tukey. And I want to look at the residual plots too, to see if we've got that line, the linear respect, if the data points are independent, if there's normality, and if the errors have similar variance. So a great way to do this is with Minitab. Again, I mentioned it's so much easier than SAS. How you do it is you come up here to your stat, go down to regression, and then, go to Anova, and then go to one-way. So we're running a one-way Anova. It'll bring up this pop-up here. And because we have multiple treatments and they're all in different groupings, or in different columns in the worksheet inside of Minitab, we will select response data are in a separate column for each factor level. And then in the responses, we just double-click in the left pane here to query all of these into the response panel. And then there's two things we're going to do. We're going to set up the graphs so that we can see the different residual plots. A great way to do that is simply clicking 3 and 1. Okay? It's going to generate 3 different residual plots that will help us evaluate our assumptions to see if the line, linearity, independence, normality, and error variation, if those assumptions are being followed. Then we're going to click on Comparison, and all we need to do is turn on Tukey. I'm going to leave these settings as they are. And click OK, and then click OK, and Minitab is going to do its magic. So you can see here that it plotted the residuals for us. Voila, just like that. You literally click one little thing and it plots each of these 3 different residual plots for us to analyze the assumptions behind our model. Okay, it gives us an interval plot. This is awesome. It gives us the Tukey simultaneous 95% confidence intervals. Again, this is awesome. And then if we look here, we can see all of the Anova data. So we'll see our Anova data. It shows us the hypothesis, what factors we're using, summary of the model. It's showing us right here the different means and the factors and their confidence intervals. And then lastly, what we're looking for, the Tukey pairwise comparison. So how this works, similar to other Tukeys you might see around, each of these factors is evaluated in comparison to the other factors in a pairwise comparison. So factor F3 is labeled with A, and so is factor F1. It is labeled with A. Because both factor 3 and factor 1 share the same grouping level of A, we know that there is not a significant difference between a 95% confidence level between F3 and F1. But you'll notice that F2 and the control do not have the A value. That means F3, which has the A, differs from F2 and control in some significant way. So this is great. The Anova tells you that there is a difference. If we look at this F value in the Anova table and compare it to an F value for these different degrees of freedom and our 5% confidence interval, we're going to see that this is significant. I mean, you can also look at the p-value. It's by far less than 0.01. So we know that there's significance, but we're not sure where. Here in the Tukey pairwise comparison, it tells us where that significance difference is. We looked at F3. Let's look at F1 now. So F1 has an A and a B on it. that means it is not statistically significantly different from any of these other factors that have an A or B label. So it is not different than F3. It is not different than F2. But it is different from the control group. And then F2, same thing. It has just a B. So we know it is not different from any other factor that has a B. F1 is the only factor that has a B. So F2, it can be inferred, is not different in a significant manner from F1. But it is different from F3 and the control group. Lastly, the control group is labeled with a C. It is the only one. Thus, each of the other factors is statistically different at a 95% confidence level from the other three factors. I hope that helps you see how awesome Minitab can be for some of these more basic, quick processes. If you haven't used it before, I encourage you to try it out.